Imagine if everything you've ever seen, every star, every planet, every galaxy, every atom in your body, makes up less than 15% of the universe. The rest? It's invisible. It's dark matter, and it's the greatest mystery in modern physics. Today, we're going on a journey to uncover the secrets of this invisible universe. Our story begins in 1933, when Swiss astronomer Fritz Zwicky was studying the Coma Cluster, a group of over 1,000 galaxies located about 320 million light-years from Earth. Zwicky was measuring how fast these galaxies were moving, and what he discovered shocked the scientific community. The galaxies were moving way too fast. According to Newton's laws of gravity and the visible matter we could see, these galaxies should have been torn apart and scattered across space billions of years ago. But they weren't. Something invisible was holding them together with its gravity. Zwicky called this mysterious substance dark matter, and he calculated that there must be about 400 times more dark matter than visible matter in the cluster. At the time, most scientists dismissed his findings. But Zwicky was right, and it would take decades before the scientific community would finally accept the existence of dark matter. So what exactly is dark matter? Here's what we know, and more importantly, what we don't know. Dark matter doesn't emit, absorb, or reflect any electromagnetic radiation. That means no light, no radio waves, no X-rays, nothing. It's completely invisible to all our telescopes and instruments. It doesn't interact with normal matter in any way we can detect, except through gravity. You could have dark matter particles passing through your body right now, trillions of them every second, and you would never know it. They pass through the Earth, through the sun, through everything like ghosts. The only way we know dark matter exists is through its gravitational effects on visible matter. It's like an invisible scaffolding that holds the universe together. Scientists estimate that dark matter makes up about 85% of all the matter in the universe. Let's put this in perspective. When we talk about the composition of the universe, we're talking about three main components. First, there's ordinary matter, accounting for only about 5% of the universe. Then there's dark energy, making up about 68%. And finally, there's dark matter, accounting for about 27%. That means dark matter is 5 times more abundant than all the ordinary matter in existence. Think about that for a moment. Everything we've ever observed is just a tiny fraction of what's actually out there. The universe is dominated by things we cannot see and do not understand. One of the most compelling pieces of evidence for dark matter comes from galaxy rotation curves. In the 1970s, astronomer Vera Rubin was studying how stars orbit around the centers of spiral galaxies. What she found was shocking. Stars on the outer edges of galaxies were moving just as fast as stars near the center. This shouldn't happen. The only explanation is that galaxies are surrounded by massive halos of invisible dark matter. Rubin's discovery was revolutionary. Another stunning proof of dark matter comes from gravitational lensing. According to Einstein's theory of general relativity, massive objects bend the fabric of spacetime. When light from a distant galaxy passes by a massive object, its path is bent. By studying these distortions, scientists can map where dark matter is located. And what they've discovered is extraordinary. Dark matter forms enormous cosmic webs stretching across the universe, with galaxies forming along these invisible threads like beads on a string. So if dark matter is everywhere, what could it actually be? The leading candidate is something called WIMPs, which stands for weakly interacting massive particles. These hypothetical particles would have mass but would barely interact with normal matter. Another possibility is axions. These are extremely light particles that could be swarming around us in vast numbers. Some scientists even think dark matter could be made of primordial black holes, tiny black holes formed in the first fraction of a second after the Big Bang. The hunt for dark matter is one of the most ambitious scientific endeavors in history. Deep underground, in abandoned mines and tunnels around the world, scientists have built ultra-sensitive detectors, waiting for a dark matter particle to collide with an atomic nucleus. But so far, despite decades of searching and increasingly sensitive detectors, we haven't found a definitive signal. The search continues with new, even more sensitive detectors being built. If dark matter particles exist, These new experiments should find them within the next decade. The Large Hadron Collider at CERN is also searching for dark matter. By smashing protons together at nearly the speed of light, physicists hope to create dark matter particles in the lab. So far, the LHC hasn't found any evidence, but it has ruled out many theoretical models. But what if we're wrong about dark matter? What if there's no invisible matter at all, and the problem is with our understanding of gravity? Some scientists propose an alternative called modified Newtonian dynamics, or MOND. However, MOND struggles to explain many observations that dark matter handles easily. Most physicists still believe dark matter is real and that we just haven't found it yet. But the debate continues. Dark matter remains one of the universe's greatest mysteries. It's everywhere, yet invisible. It shapes galaxies, yet we can't touch it. The search for dark matter is a testament to human curiosity and our drive to understand the cosmos. One day we'll crack this mystery, and when we do, it will change everything. If you enjoyed this journey into the unknown, hit that like button and subscribe to Cosmic Mysteries for more mind-bending space content. What do you think dark matter really is? Let me know in the comments below. Thanks for watching, and I'll see you in the next video.